Hi, everyone. Glad you could join us for today's session, Secrets of Top Performing DevOps Teams at Google and Beyond, with expert guest speakers Nikhil, Kaul, and Nick Pan. As you might expect from Google employees, Nikhil and Nick are super busy, so I'm grateful they found the time to speak with us about how to achieve DevOps success. And before we officially kick off, I want to take a moment and introduce our speakers. Nikhil Kaul is a product marketing manager working on CI/CD tools at Google. Prior to Google, Nikhil worked in various capacities, including product, marketing, and engineering in the software development and testing industry. Nick Pan is a customer engineer at Google. In previous roles, Nick worked as a DevOps engineer handling automated infrastructure deployments, configuration management, and monitoring. So I do think it's best to let the experts speak now. So Nikhil and Nick, the stage is yours.
Hey everyone, thanks a lot for joining us today. We are here to talk about secrets of top performing DevOps teams at Google and beyond. As Ari mentioned, my name is Nikhil, and with me I have Nick Pan, who is a customer engineer. I work on product marketing aspects of DevOps, in particular CI/CD at Google. So essentially the tools which many of you might be familiar with, which I work on a day-to-day basis, are things like Cloud Code, Cloud Build, Container Registry, and Vulnerability Scanning. I'll let Nick introduce himself, and then we can go into the presentation.
Hey folks, this is Nick Pan. Kind of as Addy as well as Nikhil mentioned, I'm a customer engineer on the Google Cloud team. Basically what customer engineers at Google Cloud do are, as there's so many folks, so many enterprises trying to move to the cloud, I work with kind of top clients in the Northeast to figure out how to build complex applications within the GCP context, so Google Cloud Platform context. Super thankful to have kind of the invitation from Addy as well as Apple Tools to invite us to talk to you guys today. We have a jam-packed agenda, and we're definitely going to dig into some fun demos that kind of showcase some of the CI/CD suite within Google Cloud. I guess a little bit about myself is that I've specialized within DevOps for quite some time now. So at Google, have always been kind of closely working with the CI/CD product team.
So before I start the presentation, I just wanted to give you a TLDR so that if somebody or many of you might end up dropping out because of other commitments, irrespective of where you are in your DevOps journey, one of the things which we wanted to showcase over here is that many of the things, tips and tricks which we are gonna share today are really coming from the Accelerate State of the DevOps 2019 report. The good part is you might be one of the first few people who are learning about this report, because this report just came out a few hours back and was launched a few hours back. For many of you who are not familiar with Accelerate State of the DevOps report, let me take a few seconds to actually introduce it and what this report actually signifies. With 6 years of research and data from 31,000 people worldwide, this report is the largest and the longest running research of its kind in DevOps. In fact, State of the DevOps 2019 report actually gives you actionable insights, irrespective of which industry or organization size you are, to actually improve your DevOps effort and ultimately become an elite DevOps team. The research is being led by Dora, with folks like Jez Humble, Nicole on the team. Dora stands for DevOps Research and Investment, and it essentially helps organizations achieve high DevOps and organizational performance with data-driven insights. So if you're trying to get more insights into what we discussed today, go to cloud.google.com/DevOps and download the report, and you will find many of the insights which we discuss over here mentioned in the report as well. But for folks over here, the way we structured this presentation is essentially into 5 different areas. The first and the foremost, we really wanted to start at a really high level and see the business impact of DevOps. The second aspect of the presentation, we wanted to touch upon, in case you're an organization who is trying to do DevOps, what are the key matrices or what are the key areas you should look at in order to see how you're performing. The third aspect of the presentation really touches on new insights in 2019, which essentially is catered to how is industry evolving as a whole, and how is industry shifting, especially when you look at from 2018 versus 2019 lens. The fourth part of the presentation, we really dive deeper into how do you balance speed with stability? And this is one of the challenges which many organizations face on a day-to-day basis. And we would actually discuss how we at Google actually look to balance speed with stability. And finally, the most important part of the presentation is what are the levers you can actually pull to improve your DevOps effort. And in this part of which is the fifth part of the presentation, we will look at two research models which would help you improve your DevOps effort. So let's start with the presentation, with the first part and the second part of the presentation. If you look at any business as a whole, it goes through different stages. You have a concept, then you start writing business cases, your development team is there, which consists of testers as well. And then your operations teams is there, and then you take the product to the market. Agile was really helpful in bridging the gap between business and development, whereas DevOps, on the other hand, has really helped us align development and operations teams, which also involves testers. The other big benefit of DevOps is that it allows us to get faster feedback from marketplace, and as a result of which your development testing team can iterate quickly on a day-to-day basis to see whether there's a product market fit and what they are releasing to the market is really what the customers want. But many a times, what the question which many of the teams are asking on a day-to-day basis, how do you actually measure DevOps performance? Or what are the key metrics you should look at when you're actually looking to see how you're doing? There are two aspects of software delivery to be measured or to be looked at when you're looking at DevOps. The first and the foremost is the speed aspect, which essentially means how fast are you releasing. And the second aspect is stability, which really categorizes to how stable are your services when you do that speed. When you're looking at speed specifically, there are two matrices which might really come in handy in order to measure the throughput or the speed. Similarly, on the stability side, there are two matrices which are really helpful in order to measure the stability Let's take these two matrices one by one to dive deeper into this speed as well as stability. The first and the foremost is when you're looking at speed, the first and the foremost matrix which would come in handy is the deployment frequency. Think of deployment frequency as something like how often does your organization deploy code? Are you deploying multiple deploys per day? Are you deploying once per week? Or are you deploying once every month? The second aspect of speed, or throughput, which you might call it, is lead time for changes. You can think about lead time for changes as how long does it take you to go from committing the code to your source control management systems to successfully running it in production. So that covers the speed aspect. Similarly, for stability, we have two specific matrices. The first and the foremost is time to restore service, which you can look as something like the time it takes from detecting a user impacting incident to having it remediated or fixed. And then the change failure rate really caters to the definition of what percentage of changes results in degraded services, which essentially require redemption overall. So those are the four matrices which you can use to measure your software delivery performance. And when you essentially look at these four different matrices across the software development industry as a whole, there are things which really stand out. The first and the foremost thing is many of us might consider speed and stability as a trade-off. The first and the foremost thing which you would see on the left-hand side of the screen is that it is possible to have speed and stability. In fact, for the 6th year in a row, the DORA report, or the 2019 Accelerate State of the DevOps report, highlights how elite DevOps teams are actually able to achieve excellence in both speed and stability without making any trade-offs. In fact, if you look at and compare the elite teams with low teams on the right-hand side, there are two things which you would notice. The first and the foremost is that elite performers are performing well or significantly better in all four different matrices which we discussed for speed and stability, whether it's deployment frequency, whether it's lead time for changes, whether it's time to restore service, or whether it's change failure rate. And simultaneously, on the flip side to that argument is that low performers actually end up doing significantly worse in all those four different areas. In fact, As industry moves to cloud computing as a whole, last year, specifically for bonus points, there is another metric which we started tracking, and that was availability, especially for companies who are trying to operate services in the cloud. You can think of availability as it is all about ensuring that the product or the service is accessible and available to your end users. It's essentially the promise we make and keep to our end users and customers. So that covers the first two sections of the presentation. We really touched into how DevOps can help. We touched into how you can measure DevOps performance, where we looked at different matrices. In the third part of the presentation, we would look at what are the new insights in 2019 which were covered and what we can learn from those insights, and simultaneously, how is industry evolving from 2018 to 2019. So let's start with the first insight, which we covered in 2019. The first and the foremost thing, which all of us should be really proud of, is as a whole, industry continues to improve, particularly among highest DevOps performers. In fact, if you look at from 2018 to 2019, one of the things which you would see is that the proportion of elite DevOps teams, the people who are actually doing DevOps well, has essentially now tripled. Even last year, there was 7%. The elite DevOps teams were 7% of the population. Now it's 20%. This also confirms the view which many of the industry analysts have, which essentially says that DevOps is crossing the chasm. The other thing which you would realize in this slide specifically is that the elite teams were a subset of high performers in 2018, whereas in 2019, this is for the first time we actually see that elite teams, there are 4 different groups consisting of elite, high performers, medium performers, and low performers. The other pretty interesting observation and statistically relevant observations which we found is that for the first time that enterprise organizations, by enterprise organizations, I mean those with 5,000 employees or more, are statistically lower. We found evidence that enterprise organizations, those with more than 5,000 employees, are lower performers than those with fewer than 5,000 employees. The role of heavyweight processes and controls, as well as tightly coupled architectures, are some of the reasons why organizations with more than 5,000 employees might be having slower speed with associated instability. There is a lot going on to this slide, but one of the things which I wanted to call out is the thing in yellow. The first and the foremost things which you would realize, which really caters to the DevOps industry as a whole, is that the strongest concentration of fully proprietary software is seen in low performers, with the reverse being true in high and elite teams. What that essentially means is that while the lowest concentration is seen among high-end performers, while the lowest concentration of fully proprietary software is seen in high and lowest performers, the rationale for that is mainly because the cost to maintain and support fully proprietary-based software can often be prohibitive. In fact, if you look at from 2018 report, one of the other things which we realized is that elite DevOps teams are 1.75 times more likely to use open source software components, libraries, and platforms. What that essentially the slide is saying is that if you are using highly concentrated, fully proprietary-based software, you probably should explore open source components in order to improve your DevOps performance. And that is particularly one of the reasons why we see a growing role of open source in DevOps. Tools like Scaffold, Kubernetes, Istio, Spinnaker have become dominant as we have moved to a cloud-native architectures. Let me speak about these tools one by one so that folks on the call have a really good understanding of what these tools can help them on a day-to-day basis. Many times, if you're a developer or a tester and you're working on a local environment, one of the challenges which you might face is getting fast feedback on your local changes. For example, if you're working with Docker, you will have to do something like a Docker build -t in order to build that artifact and get feedback. Where Scaffold really comes into handy is that it really helps you speed up your local build, test, deploy workflow, because you're not doing any of those manual steps. All of those things are being taken care of in an automated fashion. We would see this in the demo, which Nick would show in the next part of the presentation as well. Kubernetes has become the default container orchestration platform, and it allows you to manage and discover containers at scale. In case you're working in distributed microservices architecture, many a times which you will have to do is manage traffic between services, or even get things like tracing, monitoring, logging for your operations teams. And that's where Istio comes into play. Open source tool Spinnaker is a platform which Google and Netflix really contribute to. Spinnaker really shines if you're trying to do multi-cloud continuous delivery. It lets you deploy to not only Google Cloud, but also multiple platforms as well. In fact, the other reason why many customers or companies look at Spinnaker is because it comes with out-of-the-box things like blue-green canary analysis, blue-green deployment, and other things. However, if you would see, one of the challenges which we face in cloud-native world, especially if you're looking to CI/CD, continuous integration and continuous delivery, that the tooling is very fragmented. There are multiple tools which do the same set of activities. In fact, take any continuous integration and continuous delivery tool, you can essentially subdivide that tool into sub-components. The subcomponents might look something like that. There is a build trigger, which picks up the trigger from your source control. A build gets triggered. There is an artifact management repository, and then you deploy that artifact to either a cloud native environment or even your on-prem systems. What I'm saying over here is, as we have moved to a cloud native space, there is a fragmenting tooling and there are no clear best practices, while at the same point of time, there are portability constraints. This is where something like Tekton really comes into play. Essentially what Tekton is, that it is a set of shared open source components for building continuous integration, continuous delivery system, and standardizing continuous integration and continuous delivery across vendors, across environments, or across any language. What Tekton does is it provides you common building blocks for you to plug and play for extensibility purposes. In fact, it provides you avoid lock-in as well, which traditionally comes in with different CI/CD toolings. This is a quote from actually James, who works with CloudBees. Many of you might be familiar with Jenkins-X. And James speaks about how Tekton is the universal glue, which is holding three different tools together and providing you an abstraction layer with Jenkins, Jenkins-X, and Spinnaker. Recently, we have seen a strong adoption with Tekton. Red Hat recently launched OpenShift pipelines that was built on Tektons. Support for Tekton is being added in Trigger Mesh as well as Concourse team is working to integrate on Tekton components as well. Lastly, one of the most important things which we realize for elite performing DevOps teams, or teams who are able to balance speed with stability, is that cloud is a differentiator for elite performers. In fact, if you look at the data and the numbers, one of the things which you would realize is that highest performing DevOps teams were 24 times more likely than low performers to execute on all 5 capabilities which have been defined by National Institute of Standards and Technology. The next question arises is, what are the 5 different capabilities which National Institutes of Standards and Technology signifies for cloud computing? The 5 things which really caters to or defines the use of cloud computing are on-demand self-service, that you need to have a broadband network access, resource pooling, rapid elasticity, and measured service. However, at the same point of time, one of the pretty interesting arguments which we realize from the data is that most of the cloud users aren't really adopting the cloud to the full potential. In fact, only 29% of the respondents who actually said they use cloud met all the 5 criteria which NIST defines for cloud computing. What that essentially means is that it underscores the fact that organizations who are actually trying or say that they use cloud computing haven't necessarily adopted all the essential patterns that matter for driving elite DevOps performance. And that is one of the reasons what could be holding us back from reaping the benefits of cloud. There are 3 specific wins which you get when you actually use cloud or drive your performance through cloud. The first and the foremost is auto-scaling. The second is cost visibility, and the third is security. And you would see how these 3 different things can help you drive high DevOps performance in the next part of the presentation and have a lens of how things change from an on-prem world to a cloud-native world with these 3 things. So let's start with the first fast auto-scaling aspect. The first and the foremost thing which you would see, or which you might be familiar with, is that with cloud, there is no infrastructure to manage. While there is no infrastructure to manage, it also provides you fast auto-scaling capabilities. What that essentially means is that you can scale up or scale down from 0 to n or n to 0, depending upon what traffic is coming to your website. What that really helps you with is that you are not at any point of time paying for over provisioning resources. Do not have to commit to resources before you make any decisions on how much resources you want. And this full stack serverless offering, which allows you to go up and down depending upon the traffic, is really not just restricted to DevOps tooling, which includes monitoring, CI/CD, or other tools. It can also be extended to other parts of the tooling which you might be using, for example, compute offerings, messaging, databases, data analytics, ML and AI, or smart assistants in chat. The other thing which such a serverless offering really helps with is that it abstracts away scaling, capacity management, and maintenance away from your developers, testers, and operators. And the only thing which these folks have to really care about is executing the code itself while the infrastructure is being taken care of. The second biggest aspect which really helps with cloud is that you can get essentially cost visibility into your infrastructure, which can help you optimize cost. This is a really good example of Broad Institute. So Broad Institute is a biomedical and genomics research center. What you are seeing over here is that when Broad Institute ran their first genomics analysis pipeline, it costed them $45. Since then, Broad Institute has been able to optimize their cost of their pipeline by twiddling a variety of GCP knobs, and they have been able to reduce their cost from $45 per genome to $5, which essentially represents a 90% reduction. What I'm trying to say over here is that with the insights you get with things like task splitting, preemptible DVMs, persistence rigs, you're able to optimize your cost on the cloud. And finally, Shopify is a really good example of how cloud lets you manage containers and governance at scale. Shopify actually scans approximately 6,000 builds, container images every day, and stores approximately 3,030 images in their container registry. And the way they do it is by moving security to the left, by giving their developers and testers insight into security vulnerabilities as soon as container images are created, and at the same point of time, having compliance checks as a part of their DevOps pipeline, so that any container or any image which has not been checked gets deployed to the pipeline. In fact, we would see a similar kind of a demo, not at the same scale, as a part of the next part of the presentation. So the next part, we wanted to switch gears and talk about how you can balance speed with stability. We spoke about DevOps, we looked at the metrics you can use to measure DevOps performance. We also actually looked at how industry is changing in 2019 over 2018. Now let's look at how you can balance speed with stability. So take any organization. There are essentially two set of thoughts, or there are two set of personas which many of you might be familiar with. The first and the foremost is the product management team, which is being compensated on shipping products as quickly as possible to meet the customer demands. On the other hand, there are site reliability engineers, or even operations teams, or even testers who are actually ensuring that things are available and customers can use those things as desired. So many a times what you would see is that there is a push and a pull dynamic between speed and stability. So the next question arises is there a framework which we can use in order to balance this speed versus stability dilemma? Before I go into the framework, and before we tell you how the things we do it at Google, one of the first and the foremost things which I really wanted to highlight and take some minutes over here is that when you're trying to decide what kind of availability or reliabilities your service should have, just make sure that it is that having 100% reliability or availability is both unrealistic and undesirable. The reason why I say that 100% availability is unrealistic and undesirable is because of the following use cases. Suppose you're an organization and you're trying to go for 100% availability. What that essentially means, you're trying to maximize stability, and often this means that this might limit how fast you can develop new features. It also limits how fast you can meet customer needs because now you're putting your resources to maintaining that availability. The other thing which you would see while you're trying to go for 100% availability is that every incremental improve in reliability may cost you more than the previous increment because it's not a linear curve, but rather than an exponential curve. And finally, and most importantly, look at it from a user's perspective. Many a times, your end users might not even notice the difference between a highly reliable service and extreme reliable service. And while you're trying to decide what is the right availability number for a particular service, these are some of the ways in which you can come up with that number. The first and the foremost is, what is the service level expected by end users? Second, is this really revenue driving service, or is this just helping on a day-to-day basis? Third, who is the service for? Are customers paying for this service, or is this a free service? You can actually look at competitors as well to see what is the service level they provide. And finally, the cost. But it would make much more sense if I give you an example of how we would do this inside Google. Let's take the example of G Suite. So G Suite, if many of you are not familiar with, consists of things like Gmail, Calendar, Drives, Docs. Now G Suite is being used by customers as well as by enterprises on a day-to-day basis to enable the enterprise employees to perform their dirty work. If you state it in any other way, if there is an outage in G Suite, it not only impacts Google, but it also impacts the enterprise companies who are critically dependent on G Suite. Hence, if we had to set an availability or reliability number for G Suite, we would set it really high because of the impact of G Suite. Now, let's take an example of YouTube. Back in 2006, when Google acquired YouTube, YouTube was in a very different phase of business lifecycle. While YouTube had a really great product, it was still changing and evolving really rapidly. For YouTube, we set a lower availability target than our enterprise products such as G Suite because of the rapid feature development was correspondingly more important than other things. And this is where error budget really comes into handy for balancing speed with stability. Essentially, what error budgets does is that it provides you a clear, objective metrics that determines how unreliable a service is allowed to be in a single quarter. Let me explain this by an example. What happens is that your product management team essentially sets the expectation or a service level objective of how much uptime that which a particular service, let's example in this case XYZ, should have in a particular quarter. Then the next step is actually measuring that uptime by a neutral third-party system or a monitoring tool. The difference between the two numbers, which is the number set by the product management team and the number which has been measured by the neutral third party, is essentially the budget which is remaining. And as soon as there is budget remaining, new releases can be pushed. If there is no budget remaining, then you have to fix things before releasing new budgets, before doing new releases. Let me explain it by an example, another one. Imagine your product management team has a service level objective which says that 90% of all queries per quarter should be met. This means that your error budget is a failure rate of 10%. 100 minus 90 gives you a 10% number for a quarter. Now assume there is a problem, and that problem causes 2% of the expected queries to fail in a particular quarter. That essentially means with that problem, you have spent 20% of your error budget. 2 divided by 10 into 100. And then you have 80% error budget remaining to develop, which you can decide to focus on features. And if 80% if you spend those 80% of the error budget, then the new releases cannot be pushed. This is a really good example, which would allow you to give a pictorial representation of how choosing one particular availability level can really impact the allowed unavailability window in a year, quarter, and days as well. And you would say this is not a linear trend. For example, if you have an availability window or availability level of 90%, the unavailability window you have every year is 36.5 days. However, if you go for 5 nines, which is 99.999%, that unavailability window drastically reduces to 5.26 minutes. And if you go from 4 nines to 5 nines, you would see how the unavailability window reduces by approximately 1/10 of the minutes. I know that was a lot of things which we discussed over there today, but if you want to learn more about what we discussed here, which is error budgets, service level objectives, or things like service level indicators, one of the two things which I would recommend you are the books which we provide you for free. You can go to landings.google.com/books, where we provide you site reliability engineering books, as well as site reliability workbook, which provide you more insights into how you can balance speed with stability with things like error budget and other offerings. And both of these books are free. The next part of the presentation, which we really wanted to focus on, is how do you actually improve your DevOps performance? So as we were speaking about in the first slide, what I mentioned over there is that there are two ways in which you can actually pull the levers to improve your DevOps performance. The first and the foremost is the first research model really caters to how you can improve software delivery performance. And the second is the research model, which talks about how you can drive employee productivity in a DevOps world. I know there's a lot going on, so let's start with how you can actually drive DevOps performance. So rather than looking at all these lines, graphs in one fashion or simultaneously, the way I would describe is that you can read this chart in the following manner. Any line with an arrow means a predictive relationship. Any line with an arrow and a negative sign means a negative predictive relationships. What that essentially means is things like the research model for performance essentially showcases how things like, if you see my cursor here, cloud, how things like continuous delivery, how things like automated testing via tools like AppleTools, how things like having clear change management processes, how things like disaster recovery testing can actually have a positive impact on software delivery performance. The research also provides more evidence how, if you're trying to use heavyweight change processes, which my cursor shows over here, they do not work well when you're trying to improve software delivery performance. In the next part of the presentation, we really wanted to focus on these technical capabilities which are mentioned over here, which is continuous delivery, continuous test integration as a whole. And we wanted to showcase you a demo of how you actually can do these things. And while we are trying to showcase you a demo, we wanted to provide you 3 guiding principles of which you should remember while you're trying to look at the demo. The first and the foremost is we will showcase you how we are trying to improve the developer or the tester productivity within the local environment which developers or testers are using, which is their IDE. The second is how we are trying to shift left on security and trying to give insights to developers and testers as soon as they create an artifact. And the third thing which we will showcase is automated compliance, which essentially means how if something goes wrong into your DevOps pipeline, there are checks and balances to catch that. With that, I will pass over to Nick, who will actually showcase you these 3 different things in a demo.
Hey, Addy, can folks on the line see my screen?
I can see it, so I would hope so. Nikhil, can you see Nick's screen?
I can.
Okay, perfect.
Awesome, thanks so much. So kind of Nikhil wrapped up a lot of the content in terms of how we're handling DevOps within Google. Google Cloud Platform is pretty much an externalization of quite a few tools that Google has built in-house. And during this demo, we're basically going to showcase some of those core kind of workflows to basically really show you how this all works when it comes to hands-on keyboard things. So overall, the net kind of application that we're working with is going to be just a Node.js weather app. And if you look at this, it's just simple Node.js code. And then from there, I'll show you kind of what's running within development. So if you're familiar with Kubernetes and containers, this application has been containerized using a Docker file. It's a standard Docker file where basically we're just pulling kind of Node 10 and doing some commands to make sure that this is running within a container within the context of our environment. In terms of the Kubernetes manifest, just to kind of show it to the folks, you'll see here that you have these manifests. So we're going to create a deployment and a service. And I'll show you what that looks in the context of Google Kubernetes Engine. But one thing that Nikhil dug into was basically local development. So having fast iterative feedback. Google has developed a tool known as Cloud Code, which is basically a plugin for traditional IDEs, which allows you to do things like cruise through Kubernetes clusters within the Google Cloud Platform console, as well as have this fast iterative feedback, which I'll show you today. So first, I'll just kind of showcase right from your IDE, you could easily hook into Kubernetes clusters that are deployed into Google Cloud. So if I look here, I have this kind of development cluster available for me within my project, straight from my IDE. If I click in here, this will basically populate some of the attributes within the Kubernetes context. So if you're familiar with the Kubernetes space, pods can be seen as kind of units of compute or instantiations of your application. We'll see here that we already have a weather app that's deployed within the GKE or Google Kubernetes Engine cluster. And it gives you a lot of meaningful information, such as what containers are running there. So you see my weather app is running there, as well as the ability to dig into things like services. So just to kind of frame out the demo to show you what application we're working with, you'll see right from your IDE, you could pull up the external IP of what you're running within a Kubernetes cluster. So if I could click right over here, this pops open the staging environment or the development environment. And then I also have this deployed within my production environment too. So right through the Cluster Explorer, I can go ahead and check into my production environment and set this as an active cluster, and just go through that same workflow to dig in and find the service that's fronting my production workload. So kind of best practices of CI/CD and DevOps is that you want to have different environments that are uniform in configuration. You'll see here that basically we'll work through the process of changing some things on the development environment using Cloud Code, which was that plugin from VS Code, as well as then promoting that change into production over here. So just real quick to kind of showcase the Cloud Code plugin. From here, you could see that we could easily just kind of browse through our files, through our IDE. And what we'd like to do is basically, as a developer, you're always working through IDE, and we've built some tools that make it fast to have iterative feedback for local development. So you see right here within Cloud Code, we have this really interesting feature known as Cloud Code Continuous Deploy. So if I go ahead and just hit Continuous Deploy, it'll ask me to select some profiles, so I'll select the default one. And if you see here, now it's basically tracking the workspace that I'm working in, which would be the directory or the directory of my actual application code, so the weather app directory. And if you see here, it's automatically going through steps to go through the whole kind of Docker build process, the Docker tag process, the Docker push to a registry process, and then actually deploying it into Kubernetes. So we haven't made any changes yet, and we're still using that same service endpoint that I went to before. But through the IDE, it gives you this nice output where I could just click this particular link. And again, that's the same link as my local environment. And that basically shows you that service running within Google Kubernetes Engine. So that's all nifty, but just to show you kind of the power of this, let's just make a quick change to my code locally. So let's just go ahead and just make a quick background change to the CSS file. So if I just want to change this, let's say light blue or something. If I hit save, the second I hit save, the Cloud Code plugin automatically detects that we've made a change. And it begins doing this rollout process to the new or to the development cluster right in real time. So if I look here within my development cluster, I'll see that from the context of that change, we're actually deploying new pods with the new app that with the new change that we just made, so that light blue change. You'll see here that all the logs are streamed into output from the IDE. And you'll see here that Kubernetes baked in does rolling upgrades. So we're shutting down that light yellow version, and we're slowly lighting up 2 light blue versions within the development environment. So we'll just give that a little bit of time to complete. And if we go back to that endpoint for the development cluster, we'll most likely giving this refresh, we do see that we catch that light blue background. In production, we're still running light yellow. So kind of as testers, you could plug in here to basically have an endpoint for your testing or staging environment. You could have your development teams using tools like Cloud Code within Visual Studio to make changes and then check them in and push them into that staging endpoint or to that development endpoint. And then as your user experience team or your testing team goes in here, runs some tests, and everything looks good to go, you could then promote it. Just to kind of show the robustness of this tool, let's just go ahead and just make another change. And this is the change that will most likely I would want to push into production. So if I just go ahead and make this change to white again and hit save, you'll see here that the Cloud Code plugin picks up the change automatically and just keeps on iteratively running through this kind of loop of pushing it into my staging cluster or my development cluster, and then doing that rolling upgrade for you. So if we think about kind of manually or on the reduction of operations work, this would have taken a few commands, and basically Cloud Code is this nifty plugin that handles it for you out of the box. So that's all good. We've basically changed the background color to white because, to be honest, I feel like this web page makes more sense with a white background versus a light blue background. And let's just give that some time to load. You'll see here now it's a white background. So as a testing team, we look like this looks like it's good to go. And basically now we're going to go through the process of understanding what we could do to implement a proper CI/CD pipeline within Google Cloud using DevOps best practices. So we made this change, and for the most part, when you actually kind of embrace CI/CD or DevOps, you'll want to actually check this code into a version control. So I'm just going to go ahead and just do a git add and git commit of this particular file. So I'm adjusting the background to white. And then I'm just going to go ahead and just do a git push origin master. And then that is good to go. So from here, now we're trying to actually check that. We're trying to check that code into version control and have this actually be applied to the production environment. And that's when we'll kind of hover into the Google Cloud Platform console. So Google Cloud Platform is kind of a bundle of Google services that we provide for developers to build fun things. If you see here, we have a tool called Cloud Source Repositories, and clicking in here, that Git push basically synced up with this weather app repository that can support mirroring version control such as Bitbucket as well as GitHub. If we dig in here, we caught that commit, which was just checked in. And if we look here, it shows just that quick change we made from light yellow to white. If we go back to kind of the environment and what's actually happening, we've hooked up a continuous integration tool. Our tool is known as Cloud Build. And in this continuous integration tool, we'll see that we picked up that change and we've begun to kick off a build based off of the change that we just pushed. So if I click in here, let's kind of look to see what Cloud Build is doing. It'll see that we're having the status of in progress, and Cloud Build assigns a build ID to every single build. We'll see here that it's tracking that cloud source repositories through a trigger that's over here. Unfortunately, we don't have time to dig into kind of the configuration of a trigger, but basically look at a trigger as a watch for a repository that when there are changes made to it, it automatically kicks off a golden pipeline for you. And these build steps are kind of that pipeline and the core work that happens embracing your CI/CD workflow. So if you're familiar with Docker, these are pretty familiar steps. We're basically using the Docker commands to do a build of your image. So just a Docker build of that Docker file specification. We're then going to go ahead and push that image. We're going to run some testing, and then we're going to push that image into our registry known as Google Container Registry. And then at that point, we're going to deploy it to Kubernetes. One thing to dig into is that basically we host a fully managed container registry for you. So if we look here and actually dig into it, you'll see here that within the weather app repository, we have this nifty feature known as Cloud Container Vulnerability Scanning baked right in. So if I click right here for this image that we just pushed up, we'll see that we're scanning for vulnerabilities once we launch it into our registry to ensure that we're having a properly secured software development lifecycle. And kind of going ahead, since we are running tight on time and I would like to get to questions also, within Cloud Build, once you've checked that into a particular registry, you'll see that then we go through a step to deploy to Kubernetes. So this is just a simple little script. We don't have to dig into the details, but at the end of this script, we're basically just doing a kubectl apply of our YAML files. So I'll make this bigger for the group, pointed at that production cluster that's running the service for us. So we see here, perfect timing, that step just finished. And let's kind of go back to our production endpoint to take a look. So if I give this a refresh, and let's just make sure that we're not caching anything, that endpoint is now showing white. So basically end to end, we've made that change. Just one last thing to touch upon, and just in terms of kind of one of the key points that Nikhil brought on is that at Google Cloud, we stress security, and it's of paramount importance to us. One little nuance that folks might have not caught on to was the fact that there was a test step right here. So within Google Cloud, we've created this tool known as binary authorization. And what binary authorization allows you to do is make it so that you can enforce policies such as only allow images that have been built and signed and attested by my build system can be deployed into Kubernetes. So just real quick to show you what that looks like, I could easily go into my IDE here, right? And just have a terminal ready to go. And if I change my context for this cluster to my production cluster, which is this guy right over here, and I just change it over here. If you see here, if I do a kubectl get pods, the weather app that we just deployed is running within that cluster. So we're pointed to that production cluster. If I just go ahead and just do a kubectl run image, like let's say an Ubuntu image from Docker Hub, and give it a name of like HackerMan. So in the sense of maybe potentially a user trying to get a terminal into our cluster and hitting enter, you'll see here that the command line shows that the deployment has been created, and now that Ubuntu image should be launched into our cluster. But then if I go ahead and just do a kubectl get pods, we'll see that for some reason, there's no Ubuntu or HackerMan pod running within our cluster. And that's a little bit strange, right? But the reason for that is because we configured our cluster with binary authorization. So digging in here, if I look into my kind of Kubernetes engine configuration, we'll see for that particular cluster, my panic scratch cluster hardened that has kind of the best practices of security baked in. There's a little config here called binary authorization that's been enabled. This allows you to basically ensure that only trusted images can be deployed into your cluster. And we've done a lot of effort into wiring up GKE, which is our managed Kubernetes engine, to have very robust integration with these tools. So if I look at Stackdriver, which is our logging agent, and I dig into here, if I do a quick search on the HackerMan pod, this will basically pull a log from the controller that's actually handling that deployment. And if we look in right here and expand one of these particular log files, we'll see here that there is a log file coming from the replica set controller showing that this is the main one. This is the main payload. So if I just make this a little bigger and give you all some time to give it a look, you'll see here that the image that we tried to deploy through this deployment has failed because there's a cluster admission rule, which is basically that binary authorization config that I spoke to, that denied images that have not been signed by the proper attester. What this does, it allows us to ensure that only images that have been built by Cloud Build and signed by Cloud Build can be deployed into our cluster, and remediates the attack pattern, the attack vector of having someone have escalated qtTL privileges and trying to deploy malicious code into your cluster. So that was pretty much the demo, kind of an end-to-end deployment of local development within the Cloud Code context within our IDE. Being able to promote that into production using some of Google Cloud Platform's tools, such as Cloud Build, and then kind of the bells and whistles within GCP, which are things like container vulnerability scanning to check for vulnerable packages within your images, as well as binary authorization for enforcing secure software delivery. With that, that's the end of the demo. I think that we're going to pass it back to Nikhil just to kind of wrap it up, as well as with Addy for some closing remarks.
Thanks a lot, Nick. So what you saw in the demo is essentially the workflow like this. We started at local development, where you saw developers getting productive using Cloud Code because they were able to get fast feedback. Once we did a Git commit, the change which developers made from their local environment got pulled in by a continuous integration, continuous delivery pipeline. As a part of that pipeline, you saw us scanning the artifact using vulnerability scanning to ensure there were no security vulnerabilities. Then, with binary authorization, we essentially made the image which we were deploying to production was actually a trusted image because it was checking for a particular signature on that image from Cloud Build. In the previous part of the presentation, we discussed that there were two research models. The first was really impacting on DevOps performance. And this is the second model which you could use to drive productivity improvements in your organization. The way to read this model is similar to the previous model, which essentially means that lines with arrow designate and predictive relationships, and lines with arrow and a negative sign designates our negative predictive relationships. You can see over here that organizations can improve their employee productivity with smart investments in easy-to-use tools, internal search, and a culture of psychological safety. At the same point of time, what you would also notice is that improved productivity also helps us in driving work recovery as well as reducing burnout. With this, we can conclude the presentation. But before I do that, I just wanted to give you the takeaways from our presentation. The first and the foremost takeaway, what we realized is that as an industry, we are continuing to improve. In fact, if you look at the industry as a whole, the elite DevOps teams have essentially tripled from 2018. DevOps matters for both commercial goals as well as non-commercial goals. If you're trying to do DevOps, what you would see is that cloud continues to be a differentiator for elite performance. If you're trying to balance speed with stability, one of the things which we realized is having 100% availability is both unrealistic and undesirable, as incremental improvements in reliability may cost you more than the previous increment, and your users might not actually notice the difference between high and extreme reliability. And if you're trying to balance speed with stability, error budgets can be really helpful. With this, I would open the floor to questions. And one of the things, we didn't have the time to cover all the insights in the report. So I would highly suggest downloading the report from going to www.cloud.google.com/DevOps and learning more about the industry and DevOps as a whole and how we can improve with this report. Any questions here, and I'll be happy to answer them. So I see the first and the foremost question is about Cloud Code. Can you talk a bit more about Cloud Code specifically? I'll let Nick answer that since that was a part of the demo.
Hey folks, so kind of in terms of Cloud Code, what we're really trying to do is make it so that developers are able to just work out of their IDE. So when kind of Nikhil talked about that push and pull between your developers and your operations teams, developers aren't too keen or aren't too interested in the underlying infrastructure. They want to spend most of their time kind of doing what matters to them, which is kind of coding, and we're building integrations to common IDEs to make that easier. So when it comes to kind of Cloud Code, we have that really nice dashboard which shows you your clusters that you're running within Kubernetes. You could dig into the actual context of those containers, those pods, those services, and et cetera. And basically, with that tool, which was the continuous deploy, it's actually built on that underlying technology that Nikhil covered earlier in the presentation, which was Scaffold. It's another tool that Google has built and basically allows you to do that kind of fast iterative feedback to have local development cycles shorted and catching errors quicker. So we're looking to bake Cloud Code into a lot of different IDEs. Currently, we support VS Code as well as IntelliJ. So for folks who are looking to have fast local feedback, as well as maybe users of VS Code or IntelliJ that are also building Kubernetes apps, I'd suggest for you to kind of do a Google search and see if the plugin helps. And we're always welcome to getting feedback, and there's feedback features for relaying that back to the service teams.
So Nick, there's another question for you. Is the pipeline which you showcase over there, is that on GitHub which folks can use it?
That's a great question. So in terms of the actual app, we don't have it on GitHub in terms of this particular deployment. However, at Google Cloud, we have a bunch of kind of assets that allow you to get started and jump started with some of these services. There's a solution doc that walks you through kind of wiring up a CI/CD pipeline using Cloud Build, as well as hooking up and wiring up the tool known as binary authorization. Addy, not sure if we're able to kind of send follow-up messaging, but we're happy to kind of bundle that together in a follow-up email if that's a supported kind of action item.
Yeah,
sure, that's not a problem.
Okay. So there was one more question around deployment steps. So I can take that one. So essentially what you were seeing on the demo is we showcase specifically deployment steps, but you can customize those deployment steps, because what Nick showed you as a part of the demo was a YAML file, and Cloud Build, which was a CI/CD tool which you saw in the demo, lets you specifically say what steps you want to perform as a part of build, test, or deploy. So those steps can be really customized. Where can I get more info on the integrated tool set, VS Code, Cloud Source Repository, Cloud Build, Tekton? So if you go to googlecloud.com and you Google these things, you should be able to find Cloud Build, Tekton, and Cloud Code. The IDE which Nick was using was VS Code, and the plugin was Cloud Code. And
yeah, hey, Nick, I think as a follow-up, we have like an awesome CI/CD landing page that Nikhil has put extensive effort into kind of collaborating on with the engineering team to put together. So we'll definitely bundle in that link, which will give you a lot of information around all of our kind of CI/CD toolchain.
Yeah, I think there was one more question, which was regarding Google's cultural elements for DevOps. And I would say those are 4, which is using data to guide decisions, having shared fate between operators and developers and testers, having transparencies rather than secrecy and siloing data, and blameless postmortems. I would highly suggest downloading the SRE workbook, which is, as I said, free. And the workbook essentially talks more about these 4 different cultural elements and how you can implement them as a part of your organizations. I'm sorry if we're not able to answer your questions, but we will try to get back to you because there is a bunch of questions coming in. Again, thanks a lot for joining us today. Hopefully you found this really helpful.
So yeah, as Nikhil mentioned, unfortunately, that's all the time that we have for today. We even went a little bit over. I want to thank everyone that joined us for this live session. And of course, I want to thank our guest speakers, Nikhil, Kaul, and Nick Pan for this amazing presentation and demo. And before Nick and Nikhil will say their goodbyes, I just want to remind you that the link to the recording of this session with the slide deck and the link that Nikhil and Nick are putting together will be emailed to you by end of day Monday. And I hope to see you all at our next event.